you can calculate the determinant of a square matrix. The determinant is just a scalar value associated with that matrix. There is a formula, so we can start with a 2 by 2. But first of all, the notation is very important. Under this topic, which is also examined under the Edexcel conditions, determinant is given by a bold letter M, capital letter, and we can write it in short as DETM, DET, determinant of M. Or we can write it as the modulus of M, because in any case, modulus means what? Magnitude. You remember, right? Because when we're doing complex numbers, modulus of Z, which is a squared plus b squared, or it can be written as x squared plus y squared, means the magnitude of Z. So we can also write it as modulus of M, since M is a symbol for determinant, or we can just write the modulus of the 2 by 2 matrix, which in this case is given as A, B, C, D. It is also sometimes written as delta. This is a delta sign. These are Greek symbols now, okay, to refer to the determinant. So the formula of determinant, because on its own, is just a scalar quantity. The formula for a 2 by 2 of determinant is just you multiply the diagonals, the leading diagonal and the non-leading diagonal. You get the product of those and subtract. That's all. That should be are we together? So how do we, what do I mean? This is the leading diagonal, A times D, AD minus B times C. That's what we call determinant of a 2 by 2 matrix. If the determinant is 0, then the matrix M is a singular matrix. In other words, it does, these are very important, it does not have an inverse. Just like numbers like 1 over 0, we've got numbers that don't have inverses. The inverse of 2 is 1 over 2, isn't it? When you multiply a number with this inverse, you must get a what? A 1. That's the multiplicative rule, isn't it? Inverse rule. That's all. So it's much easier to know that the inverse of 1 is 1. It's much easier to know that the inverse of 2 is 1 over 2. The inverse of 3 is 1 over 3. The inverse of 2 over 3 is 3 over 2. So when you multiply a number with its inverse, it must give you 1. But because if I say the inverse of 2 is 1 over 2, you see that? So when we are calculating the determinants of a matrix and it gets on to become 0, we want to find the inverse of a matrix that has got a determinant of 0. The formula for inverse is equal to 1 over the matrix, the determinant, times the transpose. Okay, let me just write it in short. Times MT. So if this is 0, if this quantity is 0, it means 1 over 0. You don't need to copy it now because I will get to that point now. I'm just trying to explain why this has to be understood. So if this quantity becomes 0, it would mean we are going to have 1 over what? 0 times MT, of which this is undefined. No one knows how many zeros are in 1. I don't know if that will ever be known, but no one knows at the moment, isn't it? So it's undefined. Okay? So if the determinant of a matrix is 0, it means that matrix does not have an inverse. Perfectly understood, right? And what we call that type of a matrix, we call it a singular matrix. Or are we together? Singular matrices do not have inverses, okay? But if the determinant is not 0, then it is called non-singular matrix. So that distinction needs to be understood, because the exam questions, they will not tell you these things. They will just tell you that the certain matrix is a non-singular. So it's up to you to build from that key term, non-singular. So it does have an inverse, or it's a singular. It's up to you to build on that certain matrix is a singular matrix. Then they give you unknown variables, unknown terms inside the matrix. So it's up to you to say, okay, so the determinant must be equal to 0 so that I can calculate the unknown variable. So those distinctions must be known. Okay? Now, it's much easier to calculate a determinant because the formula is there. It's determinant of A, or I could write modulus of A, or I could write 6152. Either way is symbols of referring to determinant. But the formula is this, is just you multiply the leading diagonal 6 times 2 minus 1 times 5. So in this case, the answer is 12 minus 5, which I believe is 7. Example number 2 is clear, given that A is singular. What does this mean? Good. So the determinant of A is equal to 0 if A is singular. So we're looking at the determinant of A and we equate it to 0 because we have been told that it's singular. And the determinant of A is 4 times 3 minus P minus, then what? P plus 2 times minus 1, like this. And what do we actually get there? 12 minus 4P plus P plus 2, which is just equivalent to 14 minus 3P. This is the determinant of this matrix. But we have been told that it is a singular matrix. Therefore, this implies that 14 minus 3P is equal to 0. Or maybe I should just say therefore, without saying. Therefore, 14, since determinant of A is equal to 0. So if that's the case, that means 3P, this implies that 3P is equal to 14. So P is equal to 14 divided by 3. Okay? There are no conditions about the value of P to be expressed as a what is simplified to the lowest term. You can leave it like that. There is no, they didn't say put it into decimals or what. That's it. Okay. Can you copy this down quickly? Then I'm going to explain that. So if you are now asked to find a determinant of a 3 by 3 or a 4 by 4, you follow this formula. However, in most cases, you won't need to follow this formula. I'll explain why. You've got your calculators with you. Your calculator is able to calculate determinant. So unless there is an unknown variable in your matrix, you won't need to do all this method. But it's quite an easy method. Okay? So you can find the determinant of a 3 by 3 matrix by reducing the 3 by 3 to a 2 by 2 determinants using this formula. Okay? Now, how do you use this formula? It's so easy. The first term, the first column is positive, followed by the second column has got a negative coefficient, fourth column, positive coefficient like this. So what do? You take the minor of the element A, the minor of element A. It's simple to see the minor of element A. If I am to do this, if I go on element A right now and do this, do you see what I've done? I've cancelled every element from A. What I'm left with is this part here. This part here is what we call the minor of element A. It's called a cofactor. Are we together? So the minor of element A is actually a determinant of a 2 by 2 matrix, because to find this is just a determinant of a 2 by 2 matrix times A. Are we together? That's how you eliminate the minor, just like that. The next part, I said this is positive, negative, positive. So how do you find, the question is, how do you find the minor of B? You do the same thing. What do? You see? So you're left with D, G, F, I.
So was the first one the minor of A?
Yeah.
Oh,
so the minor of B, but now the B goes with the what? With a negative. That must be kept there. If it was a 4 by 4, it would be negative again here, isn't it? So you say minus B, you take the determinant of the 2 by 2. That's why we call it a minor, isn't it? It's D, F, G. It's found by cancelling the elements, the horizontal, from B. You cancel the rows and the column from B. What's remaining is that. All right? Plus C. So C, if you go to C now, you do this. That's how you're going to do it. Is that so? Cancel the row and the column from C. You're left with this minor, which is D, E, G, H, but with a plus. Are we together? So this is the formula that you would use to calculate what? Determinant. And a very good important thing to remember is this is plus, negative, plus, and also that means if I want to find the minor of D, it will be a negative, right? Minus D plus D. I can find the minor of G, but you only do for one line. You understand? You can do for this column or for this row. That's the determinant of the 3 by 3. Or you can do for this column or for any of, you can pick any point to start with. Okay? You still be fine. So this is going to be what? Positive, negative. You can follow that order. Negative, positive like this. So if I use this, I'll get this. If I use this, I'll still get everything. Same thing here. Are we together? That is the formula of calculating determinant. Quickly, let us put it into practice. Probably see that it's a very easy concept. Okay? Question. Find the minors of the elements of 5 and 7. That's or perhaps the first thing. So in other words, you are asked to find the minors, the determinant, because a minor is a determinant, isn't it? So where do you go? 5. This is 5, right? Is that so? And if I go to 5 and I cancel to find, what do? I have to cancel. I have to cross the row and column from 5. Is that so? So if I cross the row and column from 5, I am only left with the determinant of what? The determinant of 8, 7, 1, 3, which is just 24 minus 7. Sorry? This is the minor of 5. Are we together?
What about the, we see how you put A in front of it before? You have to put 5 in front of that one or no?
No. In this case, they just said the minor. They didn't say calculate the determinant, isn't it?
How did you know it was 24 take away 7? You multiply it diagonally. That's 3. Yeah.
This means determinant. So determinant is this times this minus this, which we have done here. Here. That's the formula, isn't it? Yeah? Of a 2 by 2 matrix. So the determinant of a 2 by 2 matrix here is this. Because remember, this means determinant. Minor of 5, determinant. So the determinant of a 2 by 2 is this time minus this. Together? So if we are to find, this is 5, remember, minus 1, 6, 0, 8, 7, 2, 1, 3. If we are to find the minor of 7, so we look for 7. Here is 7, right? So I'm going to cancel from 7, cancel the row and column. So in the minor of 7 is 5, is the determinant of this 2 by 2, which is 5 minus 1, 2, and 1. And the answer is just 5 minus 2, which is equal to 7. So you can write the minor of 7 is 7.
That's the end of period 6.
Minor of 5 is 17.
So you not multiply by 5 like the first one?
All right, next question. Now, what do you think this question is asking you?
Find the determinant.
Of what? Of the whole thing. Now, this is where you need, so to find the determinant of the whole thing, first of all, I want you to appreciate that. Do not forget there is a plus here. There's a what here? And there was? No, so the determinant is going to be plus 1. So it's 1, 2, 1, minus 2, 3, 1, minus 1, 3, isn't it? Plus 4, 3, 2, minus 1. Yes, please. 3, 2.
Second shape.
Oh, wow.
Yes!
Oh.
This guy's doing remark.
Remark. And what did you
One
get?
up to a 9.
From 8 to 9.
Yes.
In mathematics?
No, English.
English. Ah.
Well done, Taylor.
Thank you, man. Thank you.
Well done, young man. All right. So do we see that now? So they did not ask for the minors. This question is asking for the determinant. So this is it. Then you punch into the calculator. Obviously, the 1 here is going to be 2 times 3, 6. So that's 6 minus 4 minus 2. That's 9 minus 1 plus 4. That's 12 minus 2, which is just 2 here. This is 10 minus 20. This is 12, 14 plus 48. Fourteen times 4, that's 6 carry 1, 56. Understood? Any questions? The difference between the minor